This is your need to know. This is your need to know.
Welcome to the Deep Dive. We've got some pretty wild stuff to dive into today. Space is at it again, throwing us curveballs left and right.
You're telling me.
We've got articles here about a black hole that's, well, eating a little too much, a neutron star spinning faster than anything we've ever seen, and even Jupiter's great red spot, which, believe it or not, is changing shape.
It's amazing what's out there.
Okay, so first up, this article about black hole LID 568. The James Webb Space Telescope and the Chandra X-ray Observatory observed it, and it's growing at a rate that's got scientists scratching their heads.
Yeah, this one's a head scratcher for sure.
You're talking about this thing called the Eddington limit.
Right, it's like a speed limit for how fast a black hole can consume matter.
So, like, there's a balance between gravity pulling stuff in and radiation pushing it out.
Exactly.
And gravity usually wins, right?
Most of the time, yeah. But this black hole, LID 568, it's consuming matter at over 40 times its Eddington limit.
Whoa, 40 times.
Yep, way more than we thought possible.
So is it breaking the laws of physics?
Well, not exactly breaking them, more like bending them. This discovery supports the idea that black holes can have these short, intense feeding frenzies. It could explain how those supermassive black holes in the early universe grew so quickly.
You mean like it skipped a few meals and then went on a crazy cosmic binge?
Kind of, yeah.
That's wild.
Yeah.
So does this change how we think about black holes?
Definitely. It means they can evolve in ways we hadn't fully considered before. Now we need to figure out what triggers these growth spurts and how common they are.
Okay, fascinating stuff. Now, you sent us a couple articles about these things called fast radio bursts, or FRBs. They're these intense bursts of radio waves from deep space.
Oh yeah, those are intriguing.
One article talks about a new repeating FRB source found by the Xi-Chime telescope, and another suggests these bursts might be linked to massive galaxies.
Right, that repeating one is really interesting because it gives us more opportunities to study it. And the connection to massive galaxies suggests they might be coming from magnetars.
Magnetars?
Yeah, they're neutron stars, but with incredibly strong magnetic fields, like trillions of times stronger than Earth's.
Wow, that's intense.
It is. And these articles suggest that magnetars are more likely to form in those metal-rich, massive galaxies, maybe when two big stars merge.
So massive galaxies are like cosmic factories for magnetars.
You could say that.
And these magnetars are possibly causing these crazy FRBs.
Exactly. It gives us a potential origin story for FRBs.
Incredible. Okay, get ready for this one. One of the articles mentions a neutron star spinning at 716 times per second.
Oh, yeah, I saw that one. Amazing, isn't it?
I can barely wrap my head around that. My blender can't even spin that fast.
It's hard to imagine. But remember, neutron stars are incredibly dense. All that mass of a star crammed into something the size of a small city.
It's crazy. I even read somewhere that a sugar cube-sized piece of a neutron star would weigh 1 billion tons.
Yeah, that's about right. And this one, spinning at 716 rotations per second, it's pushing the limits of what we thought was possible.
So it's like a glimpse into some extreme physics.
Exactly.
This is mind-blowing. Okay, shifting gears a bit, you also sent us an article about Jupiter's great red spot. Turns out, it's not as stable as we thought.
Oh, right, the Great Red Spot.
It's actually changing shape and wobbling.
Yeah, observations from the Hubble Space Telescope show it's shrinking and kind of jiggling around.
I had no idea. How much has it shrunk?
Well, it used to be about 3 times the size of Earth, but now it's closer to just the size of our planet.
Wow, that's a lot. Any idea what's causing it to shrink?
Scientists think that smaller storms merging with it might be feeding it, which somehow contributes to the shrinkage.
So this iconic storm, it's changing right before our eyes.
Wow.
It makes you wonder, what's the future of the Great Red Spot?
Right. Will it eventually just disappear? Who knows?
It's a reminder that even the things that seem permanent in space are constantly evolving.
Absolutely. Space is always changing and full of surprises. Yeah, it really makes you realize how much we still don't know.
It's incredible how much our technology has advanced, though. I mean, look at the James Webb Space Telescope. It can see things in infrared, giving us these amazing views of the cosmos we've never had before.
Oh, absolutely. And then there's CHIME, constantly scanning the skies for those quick bursts of energy like FRBs.
It's like we've got these new superpowered eyes on the universe, and they're showing us things we could only dream of before. Speaking of breakthroughs, did you see that article about scientists creating a supersolid?
Yeah, it's mind-blowing. They've been theorizing about this stuff for decades, and now they've actually made it in a lab.
Remind me what a supersolid is again.
It's this bizarre state of matter that acts like a solid and a superfluid at the same time. Imagine something that can hold its shape, but also flow without any friction.
So like a ghost that can walk through walls, but also, like, hold a teacup?
Uh-huh, yeah, something like that. It's pretty wild. And they did it by cooling dysprosium atoms down to incredibly low temperatures, just billionths of a degree above absolute zero.
Billionths of a degree. That's unbelievably cold. What's the big deal about creating a supersolid, though? What does it actually tell us?
It gives us a chance to study these exotic states of matter in a controlled environment, you know? It could have huge implications for our understanding of superfluidity, quantum mechanics, and maybe even how matter behaves in crazy places like neutron stars.
So we're studying something super tiny and cold here on Earth to learn about these massive objects in space.
Exactly. It's all connected, right?
Totally. Okay, before we move on, I wanted to ask about that article on NASA's Parker Solar Probe. It's on this mission to get closer to the sun than any spacecraft before. And it's using Venus, like as a slingshot to get there.
Yeah, it's a wild mission. The Parker Solar Probe is going to fly right through the sun's corona, that outermost layer of the sun's atmosphere.
That's got to be hot, like really hot.
Oh, yeah, it'll be exposed to some intense heat and radiation for sure.
So what are they hoping to learn by getting so close to the sun?
Well, one of the big mysteries they're trying to solve is why the sun's corona is millions of degrees hotter than its surface.
Wait, what? That doesn't make sense.
I know, right? It's like the air around a bonfire being hotter than the flames themselves.
Yeah. So what else are they looking at?
They're also studying the solar wind, that constant stream of charged particles coming from the sun. Understanding it is really important because it can affect us here on Earth, you know, causing auroras, but also messing with our power grids and satellites.
Ah, so it's not just about the sun itself, but also how it impacts us.
Right. It's like space weather forecasting, but on a whole other level.
The Parker Solar Probe is a pretty amazing feat.
It really is. It shows how far we've come in exploring space and how determined we are to understand these incredible forces at work in our solar system.
It's inspiring to see how much progress we've made. It makes you wonder just how much more is out there that we haven't even begun to imagine.
It's truly mind-boggling when you think about it.
So we've talked about a lot today. I mean, we have that black hole breaking the Eddington limit, that insanely fast neutron star, and even took a closer look at Jupiter's great red spot changing over time.
It's amazing how it all ties together.
Right. Like all these discoveries, they might seem totally different, but underneath it all, it's the same laws of physics at work.
Exactly. Whether it's gravity pulling everything towards a black hole or the forces shaping Jupiter's storms, we're seeing these fundamental principles play out on a massive scale.
And what really gets me is how these discoveries challenge everything we thought we knew.
That's the beauty of science, isn't it? Always pushing the boundaries, always questioning what we think we know.
So as we wrap up this deep dive, what would you say is the most important thing for our listeners to take away from all this?
I think the biggest takeaway is just the sheer awe and wonder of it all. The universe is this incredible, mysterious place, and every new discovery just gives us a little peek into its vastness and complexity.
Well said. And hopefully this has sparked some curiosity in our listeners. We want them to keep exploring, keep asking those big questions about the universe and our place in it. And as always, keep looking up.
This is your need to know.